What's up, guys? So today we're going to be multiplying rational expressions. And like I said before, I think multiplying fractions is actually easier than adding and subtracting because we don't have to worry about common denominators. And that's going to be the same thing when we get to rational expressions. Okay, so really the whole point here is just to multiply the top times the top and the bottom times the bottom. Now, obviously, that looks like it's going to be pretty crazy to multiply, although we know we can do this. As it turns out, usually you're not going to have to, because remember, if you can factor something here first, then you can cancel out a lot of what's here, and it'll leave you with a lot less to actually multiply. So really the biggest thing we're going to be doing here is simplifying. That's probably where most of the work is going to be. So let's look at each part, each numerator and denominator, and see what can we factor, or how can we factor something out. I noticed, first of all, there's a GCF on the numerator and on the denominator here. So let's do the GCF factoring first. So I'm going to say the top is I can divide that by a 6. And so if I pull the 6 out, that's going to leave x squared plus 7x plus 12. And in the denominator, I can factor out a 4. What about the other side? On the other numerator, I can factor an x out. And I can factor out a 3x from the denominator. Now let's look at these fractions again. I'm sorry, this numerator and denominator again. Can you factor this quadratic? Are there two numbers that multiply to make 12 and add up to make 7? As it turns out, there are 3 and 4. So I can factor again as x plus 3 and x plus 4. And check to make sure. 3 times 4 is 12. 3 plus 4 is 7. The 6 is still out here. Remember, that doesn't go away. And on the bottom, two numbers that multiply to make negative 3 that add up to make negative 1. I'm sorry, negative 2. That's going to be negative 3 and positive 1. They multiply to make negative 3. They add up to make negative 2. So that works. And then we'll write the other side again. So now it's completely factored. And what's interesting at this point is if you look at it, everything on the top is going to be multiplied and everything on the bottom is going to be multiplied. So in a sense, you can think about the whole entire top and the whole entire bottom as being one giant fraction. And now that's only possible with multiplication, okay? But because of that, we can not only cancel within the same fraction, we can also cancel diagonally like this. Now you cannot do this with addition and subtraction. It's a very common mistake, and it is very much wrong. You cannot cross cancel things if that were an addition or a subtraction sign. It's only for multiplication and to some extent division, but we'll talk about that later. Only with multiplication. So what can I cancel? Is there anything on the top that cancels with something on the bottom? Is there an x plus 3 on the bottom? There's an x minus 3, but not a plus 3. What about an x plus 4? I see an x plus 4 here and an x plus 4 here. What else? There's an x minus 3 and an x minus 3. There's an x here and an x here that cancels. So a lot of stuff's going to cancel here. You could reduce the 6 and the 4, but you've also got a 3 here. So I might just say, let's cancel that 6 and 3, and that's going to be 2 over 1. So I'll put a 2 here. And then, of course, 2 and 4 could reduce to 1/2. So that's another way to think about that. You don't need to write the 1. I'll just put a 2 here. Almost everything ended up canceling out. What's left on the top? The only thing left really is an x plus 3. And what's left on the bottom? 2 and x plus 1. And I would leave it factored. As much as possible, I would leave these things factored when you're done. It's going to help you later on. And that's it. That's multiplying rational expressions. And one last problem, let's do an example for division. Now when we divide rational expressions, actually all this is multiplication. Remember that anytime you divide by a fraction, it's the same thing as multiplying by its reciprocal. A reciprocal is when you flip a fraction upside down. So instead of dividing by x minus 3 over x plus 2, I'm going to rewrite this as multiplying by x plus 2 over x minus 3. I'm just going to flip those upside down and change it to multiplication. So I'm going to rewrite the problem. To multiplication, and I'm going to flip that upside down. And now it's just a multiplication problem. And since you know how to do that, congratulations, now you know how to divide also. It's really just the same thing. So now we need to simplify the top and simplify the bottom, factoring if we can. So I can pull out a greatest common factor on the top, that would be 3x. And it looks like I can factor the bottom as well. So on the top, I'm going to pull out that, I'm sorry, not a 3x, just an x. I can only pull out an x. Pull out the x, that's going to leave x minus 3. On the bottom, I can factor this as x minus 3x plus 2. Check, they multiply to make negative 6, and they add up to make negative 1, which is the number here, times x plus 2 over x minus 3. Well, does anything cancel? Let's see, we've got an x minus 3 that cancels. You've got an x plus 2 that cancels. Actually, all you're left with is x over x minus 3, so we really didn't even have to multiply anything. And there you go.